In this part of the video, we are going to be reviewing the operation which is called multiplication. And multiplication is the action of adding a number to itself multiple times. For example, if someone said to me, multiply 3 and 5, then I could think about this as taking the number 5 and making 3 copies of it and adding the 3 copies of 5 together. Add 3 copies of 5. Or you could also think about this as adding together 5 copies of 3. If you calculate the result of these two additions, you'll find that both of them give you exactly the same answer. 5 plus 5 plus 5, if you calculate it in a calculator, will give you a result of 15. But 3 plus 3 plus 3 plus 3 plus 3, if you put it in a calculator, will give you the exact same result, 15. So you can think about multiplying 3 and 5 either way. Add together 3 copies of 5, or add together 5 copies of 3. You'll get the same answer in either case. Now, when you're asked to multiply two numbers together, there are once again a couple of different ways to do it. And one of the ways to multiply two numbers together is just to express it as repeated addition, just like we did up here. For example, if someone says to me, multiply 2 and 7, then I could achieve this by taking 2 copies of 7 and adding them together. And the result of this addition would be 14. Or I could take 7 copies of 2, 1, 2, 3, 4, 5, 6, 7. I could take 7 copies of 2 and add those together. And if I did that in the calculator, I would get exactly the same answer, 14. So it doesn't matter how you think about it. My preference is for what's on the left here because it's simpler. But whichever way you want to do it, that's fine. You'll get the same answer. It's also common to see multiplication given to you in a times table. So here is a common example of what a times table might look like. If I wanted to use a times table to calculate, for example, 2 times 7, then I would look for an entry in the table that has a row of 2 and a column labeled 7. And if I look in the table for where we have a row labeled 2 and a column labeled 7, the entry in the table that has both those features contains the number 14. And so this times table was telling me that 2 times 7 is 14. You can also do it in the other order, where you have a row of 7 and a column called 2. If you do it in the other order, 7 times 2, you get the exact same answer, 14. So multiplication is similar to addition, where you can do it in any order and you'll still get the same kind of answer. It's also possible to do multiplication on a calculator. For example, if someone asked me to multiply 2 and 7, I would enter in 2 to the calculator And then I would hit this X shape, this one here, and then I would type in my next number 7, 2, and then this X shape, and then 7, and then I would hit enter. And this is another way to get exactly the same result, 14. Now the calculator shows one of the symbols that's used to represent multiplication. One of the symbols used to represent multiplication is this X symbol. However, there are a few additional ways that multiplication can be represented. The other way to represent multiplication is to use a dot. So for example, if I wanted to say 2 times 7, I could write that as 2x7, or I could also write that as 2 dot 7. And there is another way that you sometimes see multiplication written, and that is using parentheses. Write your two numbers next to each other and put the number on the right inside parentheses. To show you an example of that notation, I would write 2 next to 7, but to make sure it doesn't look like 27, I would put the 7 in parentheses. 2 next to 7 in parentheses. This is also used to symbolically represent multiplication. So, for example, if someone says to me, what is 3 times 4? 3 in parentheses next to 4. They're asking me to multiply 3 and 4 together. So, for example, I could think of this as taking 4 copies of 3 and putting 4 copies of 3 together into one pile and count up what I have in total: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. In total, the result of this repeated addition would be 12 units. Or someone could say, what is 5 times 3? 5 times 3 with the cross symbol between them. One way to answer that question would be to go to the times table and locate an entry that has a row labeled 5 and a column labeled 3. Or vice versa, a row labeled 3 and a column labeled 5. And so the result of that would be 15. Or I could put the dot between the two numbers. And someone could say, what is 7 times 2? And so I could go to my calculator and I could say 7 times 2 equals sign. And the result of that would be 14 units. Now, what are some English words that are used to represent multiplication? Multiplication can be represented by the English word called product. Multiplication is also represented by this English word times. Multiplication can also be indicated by the English word of. Some special multiplications can be represented by the English word double. This means specifically multiply by 2. Or the English word triple, which indicates specifically multiply by 3. So, for example, if someone is saying to me, what is the product of 2 and 6? What they're asking me to do is take 2 and multiply it by 6. So, for example, if I put that in the calculator, that would give me a result of 12. 12 would be the product of 2 and 6. Or someone could say, what is 4 times 3. 4 times 3, 4 multiplied by 3. If I went, for example, to the times table and I looked for 4 and 3, then the corresponding entry would have a 12 in it. So we get another result of 12 from this product. Or someone could say, what happens if you have 3 of 7? If I have 3 sevens, 3 of 7 added together. If I add together 3 sevens, if I take the product of 3 and 7, then the result of that I could find on the calculator. 3 copies of 7 added together would be 21. Or someone could say double 15. If they say double 15, they're asking me to take 2 copies of 15. Or put another way, multiply 2 and 15, giving me a result of 30 units. Now let me give you some examples of multiplication as used in the real world. If someone makes $2,500 every month and they work for 5 months, how much money do they make in total? In this situation, if I am paid this amount of money for 5 months, then I make $2,500 in the first month, another $2,500 in the second month, another $2,500 in the third month, another $2,500 in the fourth month, and another $2,500 in the fifth month. In total, I am combining 5 copies of 2,500, 5 times 2,500. So if I multiply my monthly income with the number of months that have passed, I get a total income of $12,500. For another example, if I have a single loaf of bread which costs $4 in the store, how much would I spend if I bought 3 loaves of bread? 3 loaves of, there's that keyword, 3 loaves of this bread, which cost $4 each. I can get this by taking the number of loaves of bread that I want to buy and multiplying it by the cost for each loaf of bread. 3 copies of this $4 charge. So in total, the result of that would be 12. Now there are a couple of very special products that I would like to draw your attention to. And the first thing is, what happens if you take a number and you multiply it by 1? What happens, for example, if you have 1 of 5? If I have 1 of 5, for an example, then this would just be 1 copy of 5, 1 pile of 5 objects. So the result of multiplying 5 by 1 would just be 5 again. And if you look at the times table, you can see that this pattern shows up for all the numbers. If I multiply 1 by 1, the result is 1. If I multiply 2 by 1, the result is 2. If I multiply 3 by 1, the result is 3, and so on all the way through the table. If you multiply a number by 1, you just get back the exact same number that you started with. So, for example, if someone asked you, what is 1 times 381, you don't even have to think about this too hard, because if I multiply a number by 1, nothing changes at all. you know right away that the result is just going to be the same number that you started with, 381. Nothing changes. For another special product, what do you think happens when you multiply by 0? For example, someone says to me 0 times 4. This is asking me to add 0 copies of 4. This is asking me to add together basically nothing, right? And so if I'm not adding anything together, the result is also going to be nothing. The result is also going to be 0. And this is true no matter what. If you multiply by 0, the result is always going to be 0 because you're taking 0 copies of whatever number. You're not actually adding anything together. So, for example, if somebody says to you, what is 0 times, 54,723, you don't even have to think about this at all. The result of this product is going to be 0 automatically because 0 times any number is 0. The final special product I want to bring your attention to is if you're multiplying by a number like 10 or 100 or 1000 or 10,000, where it's 1 at the start and zeros at the end. Let's do an example and let's see if we can notice a pattern emerging from the example. If I did 10 times 74, let's put that in the calculator. I will type in 10 times 74 equals sign, and I get 740. If I do 100 times 74, and I put that in the calculator, I get 7400. If I do 1000 times 74, and I put that in the calculator, seventy-four 000. So do you see the pattern that is emerging here? If I multiply by 10, which has 1 0, then the result has an extra 0 compared to the original number, 74 with 1 extra 0. And if I multiply by 100, which has 2 zeros, then my result is just 74 with 2 zeros. And if I multiply by 1000, which has 3 zeros, then I get 74 with 3 zeros. And so this is the pattern. If you are multiplying by 10, 100, 1000, or 10,000, a number 1 with several zeros attached at the end, then all you have to do is take the number that you're multiplying by and put a matching number of zeros at the end of the number. So for example, if someone asked you to take the product of 324 and 1000, you don't have to worry about it. All you have to do is take 324 and say there are 1, 2, 3 zeros in 1000. So that's 324 with 3 zeros attached. And that would be the result of this product.